All right, here we go. Question number 9 from our Precalculus homework number 11 in MyLab Math. We have another GeoGebra problem, and it looks like we have now moved on to parabolas. They want us to graph a parabola given its directrix and focus. We're going to need to click the link to open the GeoGebra window. And it says, given the directrix and focus F for a parabola, they want us to move points A, B, and C so that they have distinct coordinates and lie on the graph. Distinct means that you can't place one dot on top of the other one. They have to be three separate points. Now, I noticed the directrix is horizontal, and here we can see the focus. One of the things you need to know about a parabola is that the vertex is going to be between the directrix and focus, and it will be equidistant from each. So I'm going to drag A and put it to where the vertex is, equidistant from the focus and the directrix, and on a line perpendicular to the directrix with the focus. And then that tells us some information. That now tells us that the vertex is at -2, 0. So over here in my scratch work, I've got some information about a parabola that has a vertical axis. Now what that means, it means that the parabola would open up or down. And if I could drag these points just temporarily to where I could illustrate that this parabola is going to open down because it has to open away from the directrix and enclose the focus. I know that I've got the point A in the right place because I know that's where the vertex goes. B and C are the points I'm not sure where they go yet. So let's make a note. The vertex, which is the ordered pair H, K, is at the location of -2, 0. Notice that gives me the values for H and K. H is -2, K is 0. Now the directrix, which I can already see is y equal 1, in our formula above, the directrix for a parabola that opens up or down is y equals k minus p. But I know k is 0, and so this is going to tell me what p is. Because if I simplify that equation, that's going to be y is -p. So from the equation, I can see that the directrix is y equals 1. So if y is 1, then I can solve for p, and that tells me that p is -1. And if you're wondering what I'm doing right now, I'm just gathering information so that eventually I can write the equation of the parabola, and then I can find the two other points. And now if we look at our equation, we need h, k, and p, and I do have all three. And so now I can write the equation of the parabola plugging in for h, k, and p. So that will be x minus h minus a negative makes that a +2 squared equals 4p y minus k. And then let's simplify. That's going to be x plus 2 quantity squared. On the other side, that's going to be -4y. And then what I can do is I can pick values for y and solve for x. Now what I'm going to do is I'm going to notice first that if I pick -1 for y, that's going to make this value positive, and it's also going to be a perfect square. That's kind of important. So here we go. If y is -1, my equation will become x plus 2 quantity squared equals +4. Again, -1 times -4 is 4. And then I can take the square root of both sides and find the x coordinates that correspond to a y-coordinate of -1. Here we go. X plus 2 equals, the square root of 4 is 2, but don't forget when you square root both sides, you need a plus and a minus. And then if I move the plus 2 over, that will give me my 2 separate x coordinates. So -2 plus 2 and -2 minus 2. So I'm going to have ordered pairs of 0, -1, and -4, -1. And now I know where to put these other 2 points on the graph. At 0, -1, and at -4, -1. And we are good. So if you have any questions or comments about anything covered in this problem, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.